Welcome to Mathema by RC YouTube channel. This is our last class of this chapter rational numbers and the lesson 12. In this previous 11 lesson, we discussed different kind of rational numbers and the properties, different kind of properties, closure properties, associative properties, commutative properties, distributive properties of rational numbers, and the number line formation of rational numbers represents the numbers in this number line form. In this exercise 1.2, and we also discussed the exercise of 1.1 also. In this exercise 1.2, we discuss that the numbers in this exercise 1.2 in your textbook. We screenshot this textbook as a whole. That the represent the numbers in this number lines 7 by 4 minus 5 by 6. Okay, 7 by 4 and minus 5 by 6 represents this number line. So in this one problem, when we solve for this, we create a number line. Okay, we create a number line, that is meant straight line. Okay, this is 0, this is 1, 1, 2, 3, 4, 5, and here is minus 1, minus 2, minus 3, minus 4. So first number is here we get 7 by 4. So 7 by 4 is a number. Okay, 7 by 4, and the next number is minus 5 by 6. Okay, 7 by 4 is a number where 7 by 4 is a number, and this is the number is when we divide this number we get less than 1. Okay, less than 2. That means because 4 into 2, that means 8. Okay, so in fraction form we get 1/2 of 3 by 4. When we represent this in decimal form, we get this number. So this number is belongs to 1 and 2, in between 1 and 2. So when we represent 1 and 2 in bigger form, this is called suppose 0, and this is 1, and this is 2. So in this form we represent this number, suppose 1 by 4. Here we get that 4 by 4. Okay, 4 by 4 is a number. 1 by 4 in previous number. 4 by 4, 5 by 4, 6 by 4, 7 by 4. Okay, this is called 4 by 4, and this is 8 by 4. Okay, so here we get 5 by 4, 6 by 4, 7 by 4, and this is 8 by 4. Okay, so this number is represents 7 by 4. Similarly, minus 5 by 6 is a number in between, in where? In between minus 1 and 0, because minus 5 by 6 is less than minus 1. Okay, so minus 5 by 6 in between minus 1 and 0. So when we represent this number, this is called 0 and this is minus 1. So we represent this number, suppose here we get 0 by 6, minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, minus 5 by 6, and then minus 6 by 6. Minus 6 by 6, that means minus 1. So this is called minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, minus 5 by 6, and minus 6 by 6. Okay, in this these numbers are in this similar scaling. In hand we represent this, so the scaling are not represented accurately. Okay, so minus 5 by 6 is this form. Okay, in similar basis we can represent this number minus 2 by 11, minus 5 by 11, minus 9 by 11. These numbers are represented in minus 0 and minus 1. Okay, so we represent this minus 0 by 11. Okay, minus 1 by 11, minus 2 by 11, minus 3 by 11, and dot 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 minus 11 by 11. This is called minus 1. Okay, so These are the similar form in between these numbers. Write 5 rational numbers which are smaller than 2. Rational numbers smaller than 2. This is easy. Smaller than 2. This is called smaller form in this left hand side, and this is bigger form. We know that. In this right hand side, the numbers are greater. That means this is can increasing and this is decreasing. So to minus less than 2. Okay, these numbers are smaller than 2. That means smaller than 2. This is called 1, 0, minus 1, minus 2, minus 3, minus 4, and the infinite number of numbers is minus less than 2. You say this portion. In similar basis, that number 6, write the 5 rational numbers greater than minus 2. That means greater than minus 2. That means this is in this right hand side. So minus 1, 0, 1, 2, 3, 4, 5, 6 and both numbers are greater than minus 2. Find 10 rational numbers in between minus 2 by 5 and half. Okay, find 10 rational numbers in between. This numbers is 3. No, not this numbers is 4. 3 is completed. 4 minus 2 by 5 and half. Okay, this is 4 minus 2 by 5 and half. We create these numbers as an easy basis. In this previous class we discussed, suppose here we discussed 2 methods of the rational numbers in between 2 numbers. That means the minus 5 by 6 and 5 by 8 we get these 2 numbers. Okay, how it can possible? These numbers we represents in similar basis in this example. So here the LCM. So here the LCM of 5 and 2, this is called 10. Okay, LCM of 5 and 2, this is called 10. So minus 2 by 5 into 2 into 2, 2 by 2. Okay, therefore 4 by 10. This is similar by minus 2 by 5. Okay, similar half into 5 by 5, that means 5 by 10. Now we represent these numbers minus 4 by 10, minus 3 by 10, minus 2 by 10, minus 1 by 10. Okay, 0 by 10, that means 0. Okay, then 1 by 10, 2 by 10, okay, 3 by 10, 4 by 10 and then 5 by 10. So here we get numbers 1, 2, 3, 4, 5, 6, 7, 8 numbers. Okay, 5, 6, 7, 8 numbers. Now these are the numbers, 8 numbers, but here we get 10 numbers. Suppose here get the 10 rational numbers. Okay, this is the 8 numbers in between these numbers. Now we also represent these numbers in between. Here we get in between 2 numbers. Okay, so this are the this is the form. Okay, in this now we get 2 by 5. Okay, into 4 by 4. Okay, this is called minus 8 by 20. Now it is, and half into 10 by 10, we get 10 by 20. We get 10 by 20. So here we get minus 8 by 20. This is similar minus 2 by 5. So minus 7 by 20, minus 6 by 20. Okay, minus 5 by 20 and dot 1 minus 0 by 20, here 1 by 20 and dot quota 9 by 20 and also 10 by 20. We get the most numbers between this 10 by this portion. Okay, and we also find out these numbers, numbers in between 5 rational numbers. And the another way is, this is called the midpoint theorem. Midpoint numbers is then 2 by 3 and 4 by 5. 2 by 3 and 4 by 5 get, when we get 2 by 3 and 4 by 5, both numbers are belongs to, okay, 2 by 3 and 4 by 5, both numbers are belongs to, here called 0, and this is 1, because both numbers are less than 1. So here we get suppose 2 by 3, and here we get suppose 4 by 5. So first we midpoint this number, that means this, okay. So how we can midpoint? We add these two numbers, 2 by 3 plus 4 by 5 divided by 2. Okay, so first we LCM these two numbers. Suppose these numbers are LCM 15, so we get 10 plus 12, that means 22 by 30, that means 11 by 15. This is an numbers. Okay, now when we get 11 by 15, now we midpoint 2 by 3 and 11 by 15, also 11 by 15 and 4 by 5. Okay, these are the midpoints. So we can create these numbers in infinite number of positions. So okay, we get these numbers also. Find the rational numbers in between 3 by 5 and 3 by 4. The similar case. This the easy part. Easy part is that we can create LCM, and then we get the numbers in ascending or descending order. Okay, thank you for this class. In this next class we discuss another part of this chapter, that is summary of this chapter, and also we start a new chapter of this class. So stay with us and subscribe our YouTube channel. Join in our Telegram group. In this description, go to get you the Telegram link. Thank you for your next class. See you again.